Hello and welcome to all in this video lectures series on 8051 microcontroller. We are discussing the timer section present in 8051 microcontroller, and in this video we are going to talk about one of the two important SFRs associated with timer section of 8051 microcontroller, that is TMOD, that is Timer Mode Control Register, and TCON, Timer Control Register. So let's begin. So when we talk about this TMOD register, the TMOD stands for Timer Mode Selection Register, right? And when we talk about it, it is basically an 8-bit register, right? And these are the bit configuration, that is M0, M1, C/T bar gate, again M0, M1, C/T bar gate, right? And as said, this TMOD register is basically used to set the various timer operation modes here. Okay, so it is as said, it is totally the 8-bit register, out of which the lower 4 bits are used to set the proper mode of operation for timer 0, whereas the higher 4 bits are used to set the mode of operation for timer 1, right? So here again we are going to focus M0, M1, C/T bar gate. These are the lower 4 bits, and same are replicated as higher 4 bits. So whenever we are going to deal with timer 1, I am going to make use of lower 4 bit to set the operation for timer 1, and to deal with the timer 0, we are going to use the lower 4 bits here, right? So again, out of this 4 bit, the lower 2 bits, that is M0 and M1, these are used to set the timer mode operation, whereas the C/T bar and gate, these 2 bits are used to specify the operation. For example, here we know that the timer block is capable to work as a timer in which the internal clock source is used, or even it is used as a counter when it is going to work as simple the event count. So whenever we are going to make use of timer 0 in timer mode, right? So C/T bar, so the status of this bit we have to make as a 0, right? So when the C/T bar is equal to 0, the timer 0 is going to work into the timer mode, whereas if we are going to set this to 1, then timer 0 is going to work into the counter, and the same is true for the timer 1 here. Okay, so when I'm going to talk about the configuration of M0 and M1, right? So these 2 bits are going to define the mode of operation for timer. It may be for timer 0 or it may be for timer 1. So basically, the 4 different modes are supported by the timer section, which is present in 8051 microcontroller. Okay, so the first mode is basically called as a mode 0. The second mode is called as a mode 1. The third mode is called as a mode 2. And the last mode, that is the fourth mode, that mode is called as a mode 3 here. So whenever the status of M0 and M1 bit is equal to 0, 0, then the mode 0 is selected, in which the timer is going to work as a 13-bit timer mode here, right? In such a way that out of total 16 bits of timer, right? So here for the discussion, let us consider the timer 1. Suppose I am going to deal with the timer 1 here, right? Then out of the total 16 bits of timer 1, only 13 bits are used here. Okay, and these 13 bits are used in such a way that all higher 8 bits and out of lower 8 bits, only 5 bits are used in this mode here. So in this way, out of 16, higher 8 bits and lower 5 bits, in this way total 13 bits are utilized in mode 0. The second mode, when we are going to configure the status of pin as a 0, 1, so that is called as a mode 1, in which the timer is going to work in a 16-bit timer mode. Okay, means all the 16 bits which are present, that is lower 8 bit and higher 8 bit, all these 16 bits are utilized when it is configured in 16-bit timer mode. The next mode is basically called as a 8-bit auto reload mode, right? So when the M1 bit is 1 and M0 bit is 0, in that case this simple 8-bit auto reload mode is used. The 8-bit auto reload mode is going to work in a such a way that the required count value is loaded into higher 8-bit, and the moment at which we start the timer, automatically it is get loaded into the lower 8 bits, right? Okay, so this is called as a 8-bit auto reload. And the last one is called as a split timer mode, in which the timer 0 is used as a two timer, say lower 8-bit as timer 0 and higher 8-bit as a timer 1. Okay, so this is one timer and this is a second timer. In this way, whatever the 16 bits associated are there for timer 0, right? These 16 bits are used as a two different 8-bit timers. Okay, so in this way, this M0 and M1, these two bits are used to select the proper mode of operation for timer. It may be 13-bit timer or counter mode, it may be 16-bit timer or counter mode, it may be 8-bit auto reload timer or counter mode, or split timer mode here. And the same is applicable for timer 0. Okay, now here as discussed, the C/T bar, this is the next bit. If I am going to make the status of C/T bar equal to 0, then the required or the selected timer is going to work into timer mode, whereas if I am going to make it as a 1, then the selected timer is going to work as a counter, means into the counter. And the next one is a gate bit. Okay, so this gate bit is used to turn on the timer along with the hardware control. For example, when the gate bit we are going to enable, then the INTX pin is high and RX this means the external hardware interrupt and timer start being pin, that is a bit, sorry. When both these bits are high, then and then only your timer will start here, right? Means for timer 0, I will say INT 0 bar and TR1, and for timer 1, INT 1 bar and sorry, here it is TR0 and TR1. So these two bits are going to define the turn on a timer, right? So here out of which the INT 0 bar and INT 1 bar, these two bits are nothing but associated with the hardware, and that's why it is said that whenever we want to turn on the timer with software and hardware control, in that case the gate bit is set to 1. So generally we are going to most probably we are going to rely on the software control, means we are going to make this bit equal to 0. Okay, now let us discuss all this in detail, right? Before going to start the same, let us have the quick discussion. Suppose the value of TMOD is 01H. So let us find out which timer is selected in which mode. Okay, so now the TMOD hash 01H. So as it is a 01 means higher 4 bits are equal to 0. Okay, and out of lower 4 bit it is a 0, 0, 0, 1. Right, means the timer 0 is selected in mode 1. Right, so here the timer 0 is selected in mode 1. The second instruction, move TMOD hash 20H. Right, so for move TMOD hash 20H, right, what will be the content? As it is a 0, then it is 0, 0, 0, 0, and for 20, 0, 0, 1, 0. Okay, so as it is a 1, 0 means what? Simple, the timer 1 is selected and the timer 1 is going to work in mode. Right, so timer 1 is working in mode. The next, move TMOD hash 12H here. Right, so corresponding to 12, 0, 0, 0, 1, so this represents 1, and 0, 0, 1, 0, this represents 2. So what is happening? Simultaneously we are selecting two timers, timer 0 and timer 1, out of which the timer 0 is working in mode 1. Okay, the timer 0 is working, it's 1, 0, right? So timer 0 is working in mode 2, whereas the timer 1 is working in mode 0, mode 1 here. Okay, so timer 0, mode 2, and timer 1, mode 1. So in this way, by configuring this TMOD register, we are going to deal with the timer operation. And if you see everywhere, right, in all these 4 instructions, okay, this bit, here also this bit, and here this bit and this bit, right? So these bits are nothing but C/T bar, they are made equal to 0. Means in all these 3 examples, whatever the 16-bit timer is available, that 16-bit timer is operating into the timer mode, right? So this is the way in which we are going to select the proper timer in specified mode of operation. right? The next register is a TCON register. So TCON stands for timer or counter control register. Basically, it is again a 8-bit register and it is bit accessible. Means with the help of some instruction, directly we can set or reset only individual bit of this TCON register. Whereas the TMOD register is not a bit accessible. You can't directly configure like set bit C/T bar, somewhat like this. It is not supported. For whom? For the TMOD register. But here the individual bit we can set and reset with the help of available instructions. So out of this 8 bit, the lower 4 bits are associated with the interrupt control structure. Right? So we are going to discuss this in another session when we are going to talk about the interrupt structure of 8051 microcontroller. And out of the 8 bit, the lower 4 bits are the higher 8 bits are purely used for timer operation. And these are mainly used to turn on or off the timer. Right? These bits are used to turn off or on the timer. Right? For example, here if you see, the D7th bit, or I can say TCON.7th bit is a TF1, then TR1, TF0 and TR0. So what will happen? The TF1 stands for timer 1 flag. Okay. The TR1, okay, that is TF1, timer 1 flag, TF0, timer 0 flag. TR1 and TR0, these two bits are used to turn on or off the timer. Right? So what will happen? The moment at which we will make TR1 is equal to 1, the timer will start. Start means what? The whatever the initial count value is there, that count values goes on incrementing. Right? And when TR1 or TR0 bit we make 0, then timer stops. Okay, means there is no any increment. Whatever the value is there, that value remains as it is present into the timer. Whereas there is a concept. The concept is known as a rollover concept. So now what is that rollover? Let's discuss that first. As we said, the timer is having 4 different modes here. Right, so the first mode is basically called as a 13-bit timer or counter mode. Right, so when I am going to talk about 13-bit timer or counter mode, so 2 raised to 13, so the value starting from 000H to the maximum value that it can hold is a 1FFFH. Right, in case of 16-bit timer or counter mode, what will happen? Total 2 raised to 16, so the initial value is 0000H and the final value is a FFFFH. And for 8-bit auto reload mode, as we are going to deal with only 8 bits, 2 raised to 8, so the initial value is a 00H and the final value is a FFH. Right? So these are what we call the minimum and the maximum values that can be held by the timer into different modes. Right? If I am going to configure the timers, either timer 0 or timer 1 in say simple, in mode 0, then I am utilizing the 13 bits. In mode 1, I am using all the 16 bits. In mode 2, I am using only 8 bits. Right? So the minimum value is what? 0000 to 1FFFH. Right? So in short, what is happening? Okay. So as we have seen the internal architecture, we are having this clock source. And from this clock source, okay, the pulses are provided to this timer section or the timer register, I will say. Right? It may be any. Okay, suppose if timer is going to work first initially into mode 0. So what will happen? The moment at which I am going to turn on the timer corresponding to each of these pulse, suppose the initial value present is 0000H. Right? So when the first pulse is given to timer register, okay, suppose for the sake of simplicity consider we are using the timer 0. When the first pulse is given, the value present in timer 0 is get incremented by 1. When the second pulse is received, right, the values get incremented by again 1. So the new value is 2. When the third pulse is received, then the value is what? 0003. Then 0004. In this way, as we are utilizing the 13-bit, in mode 0, the values get incremented up to 1 F, 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 H. Right. So this is a maximum value that can be held either by timer 0 or timer 1 in mode 0. Right. Now let us consider I am going to configure this in timer mode 1. Okay, timer 0 in mode 1. So what will happen? The initial value is 0000H. Then what will happen? When the first pulse is received, the values get incremented by 1. And the second pulse is received, again the values get incremented by 1. So in this way, its maximum capacity to hold the values what? F, 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 H. The values goes on incrementing up to F, 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 H. Right? And if I am utilizing a simple, what we call the final, that is 8-bit mode, right? So the value present in TH is, suppose initially it is a 00, and when I am going to turn on this, the same values get automatically loaded into TL. So the initial value is 00, get incremented by 1 every time when the clock pulse is received, and the maximum value that reached is what? FF. Right? So these are what? These are the maximum permissible limits. Right? And even after reaching to the maximum limit, right, the next clock pulse is received by the timer. Then what will happen? Now the timer is going to get resetted to value 0000. Right? Even here also 0000 and even also 0000. Right? And this concept is basically called as a timer overflow. Means after reaching to its maximum value, when the next pulse is received, the timer is going to increment its count by 1 and automatically the values gets to 0. In other words, this concept is called as simple rollover. Right? So what is rollover? The timer is going to reach its maximum value, and after reaching the maximum value, still the clock pulse is received. Right? So the content present in the specific timer is reached to 0. So this concept is called as a rollover concept. Right? And this rollover basically denoted by this TF, that is a flag bit. So right from its minimum value up to maximum value, the status of TF bit is equal to 0. And the moment at which the overflow occurs, the TF is going to change from 0 to 1. So whenever the value of TF is 0, no doubt whatever the count value present in the timer is within its permissible limits, and when it is going to change from 0 to 1, it indicates that now the timer has been overflowed. That means the rollover is occurred, and now the content are equal to 0. Right? So that is indicated by this TF. So because of this, when I am talking about this timer flag, right, whenever a rollover is occurred for timer 1, the TF1 bit is set to 1. And this thing is happening automatically. The internal block is going to do this, right? Automatically it is going to change the status from 0 to 1. Similarly, when timer 0 is overflow or rollover occur, in that case the TF0 flag is set. Right? And this also done automatically by the internal circuit. Right? So this is about the rollover and the TMOD and TCON register. So in short, right? So when I am going to talk about the timer operation, so this is the most important, that is C/T bar. Right? So when I am going to make the status as a 0, when I am making the status as 0 means what is happening? The clock pulses. Consider at this moment also the external clock pulses are present because of transition on pin T0, and here also we are there with some clocks which is generated from the internal on-chip oscillator. So when I am going to make the C/T bar from TMOD register equal to 0, then this internal clock source is selected. Right? Means now the clock is going to move from here up to this point. As we are not interested into the external hardware control here, right? So because of that, I am going to make it 0. Then it is moving in upward direction, and here. So this is the most important one, right? So TRN. Suppose I am using timer 0, then this bit represented as TR0. When I am using timer 1, this bit is represented as TR1. So by default, status of TR0 and TR1 is 0. So what is happening? When it is 0, the proper connection is not there, in the sense not a single pulse is given to this time, right? But the moment at which, say this upper portion, this represents 0, this represents 1. And the moment at which I am going to make this bit, that is TR0 or TR1 bit as 1, what will happen? These switches get closed, and whatever this train of pulses are there which are present here, right, are transferred as it is to this timer register. And because of that, say initial value is say 0 0 0 0 0 0 0 0 0, right, 0 0 0 0 0 0 0 0, right. When the first clock pulse is received, the value is incremented by 1. For second clock pulse, the values get incremented by 1. For third clock pulse, incremented by 1. For fourth, incremented by 1. For fifth, in this way, right. So in this way, this TL content as well as TH content sub goes on incrementing. And for 16-bit mode, what will be the last hold value? 1111 1111 1111 1111. That is what FFFFH, right. And when the next still clock pulse is given, the values are get changed to 0000 000 000 000 000, right. And this is called as what? Simple the concept of roll, right. And whenever the value changing all ones to 0, the TFN, where n is equal to 0 or 1, this flag is set. So in this way, the TMOD and TCON registers are basically used to control the mode of operation for timer as well as to start or stop the timer.